right, so our next and final operation with radical expressions is dividing. So we've talked about how to simplify, add, subtract, multiply yesterday, and so our last thing we need to do is talk about dividing. All right, so as a warm-up here, just need to find the area of this rectangle. Pause your video and see if you can do that. All right, so again, when we find the area of a rectangle, area is length times width, right? And they gave us both of those in this problem. So I'll have the area will equal the length. Usually we'll call this one the length, so I'll do 3 radical 12 times the width, which we'll call 4 radical 3. And we learned yesterday how to multiply our radicals, right? We multiply outside times outside. So 3 times 4 gives me 12, and that's going to stay on the outside, right? And we do inside times inside. So I need 12 times 3, and that answer is going to stay on the inside. 12 times 3 is 36. So I'm going to have 12 radical 36. Now, like we talked about yesterday, we are not done because we need to check and see if we can simplify. It just so happens that the square root of 36 is a perfect square, right? Square root of 36 is 6. So my area is actually going to be 12 times 6. And 12 times 6 gives me 72. So if I had units, it'd be 72 units squared. But since I don't have units, we'll just call it 72. So a good review of multiplying from yesterday and seeing that in a situation that isn't just multiply these two numbers, right? Area is a very common way where you'll see multiplying, especially with radicals. So outside times outside stays outside. Inside times inside stays inside, right? Okay, so that was a review of multiplying. So now let's talk about dividing. So here's our first one, the square root of 16 divided by the square root of 81. Remember in algebra, whenever we see dividing, it's going to show up as a fraction, right? So when you see that fraction bar, think divide. Hopefully this one is jumping out at you of saying, hey, hang on, those are perfect squares, right? What is the square root of 16? The square root of 16 is 4, right? And the square root of 81 is a perfect square. What is the square root of 81? The square root of 81 is 9. So my answer is 4 over 9. And I can't reduce that fraction, so that's how it is. That's dividing radicals. You can do it. It's no big deal, right? Okay, so now let's look at number 2. Here I have a giant square root of 25 over 49. Now, just like with multiplying, I could multiply two things inside the radical, or I could put it all in the radical, right? So this is the same thing as saying the square root of 25 over the square root of 49. So you can have a giant square root sign over a fraction is the same thing as splitting that fraction into two different square roots, top and bottom. And then you'd look at this and say, oh, well, square root of 25, that's 5. And the square root of 49, that's 7. And since I can't reduce that fraction, 5 over 7, there's my answer, right? So you can either see dividing radicals showing up as two separate radicals, one on top and one on bottom, or you can see it as a giant radical with a fraction inside that's still dividing radicals, and it means the same thing. All right, so now what if we kick up a notch here? Here I have square root of 81 over 4x squared. So again, this is the same thing as splitting it into two separate radicals, one on the top, square root of 81 on the top, and on the bottom, the square root of 4x to the 4th. Okay, well, square root of 81, it's a perfect square. That would be 9, right? Square root of 81 is 9. On the bottom, I have the square root of 4. That's a perfect square, right? That's 2. And I have the square root of x to the 4th. That's an even exponent, so that's a perfect square as well. The square root of x to the 4th is x to the 2nd. So I have 9 over 2x squared. Since I can't reduce 9 over 2, there's my final answer. All right, now number 4, I have the square root of 32 over 18. Now this one's a little bit trickier, right? Because if we just split it up the way it is, I have the square root of 32 on the top, and I would have the square root of 18 on the bottom. Now, neither one of those are perfect squares. But I do think I can simplify them, right? The square root of 32, that's the square root of 16 times the square root of 2. And the square root of 18 is the square root of 9 times the square root of 2. So on the top here, see, square root of 16 is a perfect square, so that would be 4. Radical 2 is not, so it's going to stay put. On the bottom, I have the square root of 9 as a perfect square, so that's going to be 3. Radical 2 is not, so that's going to stay put. Oh, see, now I have a square root of 2 on the top and a square root of 2 on the bottom, and I know how to reduce fractions, or same thing on the top and the bottom. Those are going to cancel out. So my final answer will just be 4 over 3. All right, so we can still divide with radicals even if they're not perfect squares. However, there was maybe an easier way to do this. If I go back to the beginning, I'm going to bring this back up exactly how we started it. Big square root sign of 32 over 18. Now, what I always highly recommend is if you have this fraction inside this radical, or even if you have a radical on the top and a radical on the bottom, as long as whatever you have there is both on the inside of the radical, see if you can reduce your fraction first. Reduce first. 32 over 18. 32 over 18. Well, I know I can for sure divide both of those by 2, right? Let's try that. Let's just divide by 2. So I get the square root of 16 over 9. Holy cats, that's way easier, right? Now you could rewrite square root of 16 over square root of 9, but at this point we know it means the same thing. So that means the square root of 16 is 4, the square root of 9 is 3, and that saved me some work, right? Not only did I not have to try and break down those bigger numbers into their perfect square factors, but it was a heck of a lot easier to deal with those numbers once they were smaller. So always try to reduce those fractions first. All right, let's take a look at this one now. Square root of 4 over 10. So we just talked about it. I think I can reduce that fraction. I can divide both of these by 2. So this is going to become the square root of 2 over, well, maybe I'll just write it this way, square root of 2 over the square root of 5, right? Neither one of those are perfect squares. So that's kind of all that I can do there, right? Now, maybe some of you said, like, hang on, though, if you didn't reduce, this could have been, so let's just say this, 4 over 10, right? If I didn't reduce, and you said, well, square root of 4, that's a perfect square. So that would have been 2 over square root of 10 is not a perfect square. But wait, that's the same thing, and all I did was one step, and I'm supposed to get the same answer. But as you can see, on the top I get radical 2 over radical 5, and on the bottom I get regular old 2 over radical 10. Those are not the same answer, but it's the same problem. They should be the same. So because of this situation right here, we kind of have a rule when we're dealing with dividing and radicals, is that we can never leave a radical in the denominator. Can never, actually we don't want to really need the word can, right? Oops, I meant to get my eraser there. Never leave a radical in the denominator. And this is the reason right here, is because if you leave a radical in the denominator, you can have multiple different answers to the same problem. And that just doesn't work, because then we'll never know if we have a correct answer or not. And we want it to be the most simplified it can be. So to have a simplified radical, we cannot leave a radical in the denominator. So then your question might be, well, how do I get rid of it, right? A lot of times, many people think that you would just square the whole thing. But we have a problem with that when I'm not solving, right? If I just had the fraction 1/5, is it the same as if I squared the whole thing? 1/5 is not the same as 1 over 25, right? Those are two different things. No way, not the same. So I can't just square the whole thing. That would be a way to get rid of my radical, but it wouldn't keep my fraction the same value. It would change the value of the fraction. Instead, what I can do, let's say if I had 1/5, I could multiply the top and the bottom by the same number, right? That would give me 5/25. That is the same thing. That did not change its value. When you multiply the top and the bottom by the same thing, it's multiplying basically by 1, right? So it won't change the value. So if I want to get rid of the radical in the denominator, what I need to do is multiply both the bottom and the top by that radical. It's like multiplying by 1, so it won't change the value. And watch what happens here, right? Square root of 2 times the square root of 5 on the top becomes the square root of 10. On the bottom, the square root of 5 times the square root of 5 is the square root of 25. The square root of 25, that's a perfect square now. So this becomes square root of 10/5. Now notice, when you multiply a radical times itself, right? Square root of 5 times the square root of 5. It's like squaring it, right? And that's the opposite of a square root. So when you multiply a radical times itself, the radical disappears and you're left with just the number inside. Square root of 5 times the square root of 5 is 5. Square root of 10 times the square root of 10 is 10. The square root of 2 times the square root of 2 is 2. All right? Now you can write this middle step if you want to, this guy right here, or you can go straight to just the plain old 5 on the bottom. Either way is perfectly fine. But notice how we now do not have a radical in our denominator anymore. Radicals up top, perfectly fine. Radicals down at the bottom, not okay. So if I look at my second option here, down at the bottom, I had 2 over radical 10, right? Well, if I want to get rid of that radical on the bottom, I need to multiply by radical 10 on the top and the bottom. Outside times, I got an outside and an inside on the top, so that's going to become 2 radical 10, right? Neither one are in the same spot, so they're just written next to each other. On the bottom, radical 10 times radical 10, well, that's radical 100, but the square root of 100 is a perfect square, so this becomes 2 radical 10/10. The only thing is with this one, now, if you notice, I have a 2 on the outside and a 10 on the outside. I need to reduce. If I covered up that radical 10, my fraction would be 2 over 10. That I need to reduce, right? I need to divide both of these guys by 2. This is going to cancel up on top. This can become a 5 down at the bottom, so I'll have radical 10/5. And look at that. Now I have the same answer. And so that's why we need to rationalize. That's what we call rationalizing our denominator, and this is why. So not leaving a radical in the denominator, this is called rationalizing the denominator. Fancy vocabulary, but that's what it means, right? Remember, when you have the square root of a non-perfect square, it's an irrational number. And if you change it to a regular number, that's rational. So we call it a rationalizing the denominator. All right, big idea though is that when you want to clear a radical off the bottom of a fraction, we multiply both the bottom and the top of that fraction by the radical in the denominator. That's the big idea here. All right, now number 6 says 4 radical 10 over radical 6. Now, I do see that I have a radical in the denominator right now. However, remember, our rule was to reduce our fractions first. Now, notice in this time, this is showing up as a radical on the top and a radical on the bottom. But notice both the 10 and the 6 are on the inside of the radical. So I can reduce them because they're both on the inside. So I'm going to divide them both by 2. So I get 4 radical 5 over radical 3. Okay, a little bit easier numbers to deal with now, but I still have a radical on the bottom. Sometimes if you reduce like that first, you won't even have a radical on the bottom. Either it'll cancel out completely or it'll become a perfect square and you won't have anything to do. So I highly recommend you reduce first. This one, I still have a radical on the bottom. Great practice for how to clear that radical. Remember, I want to multiply the bottom and the top by the radical in the denominator. I want to clear the radical 3, so that's the one I need to multiply top and bottom by. Okay, so let's see. 4 radical 5 times radical 3. Inside times inside. So I have 4 radical 15. And the denominator, I have radical 3 times radical 3, which is going to give me 3. Notice I kind of skipped that middle step, right? We talked about it. You could write the radical 100, like on this one right above it, we could write the radical 100 and then the 10. We could write the radical 9 if we want to, and then the 3, but it's okay to just skip that step now completely and just go straight to the plain old 3. I didn't mean to erase the 3. That's perfectly fine. Okay, now notice on this, the 4 is on the outside and the 3 is on the outside, so I can't reduce those. The 15 is on the inside and the 3 is on the outside. I can't reduce those. So this is simplified as much as it can be. And notice how when we reduce first, it saves us a bunch of time that way. All right, couple of our last two here just to make sure you're really understanding this idea of reducing and clearing that radical off the bottom. Okay, number 7, 2 over 3 radical 7. I see I have a 2 on the outside and a 3 on the outside. Can't reduce that. 2/3, nothing I can do there. I do have a radical in the denominator though, which I need to get rid of. Now I don't need to multiply by the whole denominator, only the radical part. The 3 is perfectly fine where it is. That's no big deal. What I can't have down there is the radical 7. So the only thing I'm going to multiply by here is just the radical 7. On the top, the 2 is on the outside and the 7 is on the inside, so I can't combine anything. They just stay exactly how they are. On the bottom, the 3 is still going to just stay put, right? But now I have radical 7 times radical 7. And so that's going to become 7. Now notice I'm multiplying these, right? So I'll have 3 times 7 down at the bottom. If that was a little confusing for you, we can write the radical 49 here on this one if you want to, just so you can wrap your brain around it a little bit easier. Okay, so down at the bottom now, I'll have 3 times, right, the square root of 49 is 7. And on the top, I still just have 2 radical 7. So now I'm going to have to do the 3 times 7, which is going to give me 21 on the bottom. So I'll have 2 radical 7 over 21. 2 over 21, I can't reduce it all, so there's my final answer. So remember, if you have a number on the outside and a radical down at the bottom in the denominator, the only thing you need to multiply by is just the radical part. All right, last one for you to try here, number 8. Big square root of 88x to the third over 11x. Now remember our rule of reduce first. If you didn't on this one, if you took a shot at this one on your own and you didn't reduce first, yikes, this would be a tough problem. But watch what happens when you reduce first. Here I see I have 88 over 11. I can divide those, right? That's going to become just 8. Now be careful, make sure everything you have here is still in a square root sign. Then I see I have an x to the third over an x to the first on the bottom. Now think back to the last unit. We know what to do there, right? When I have like bases and I'm dividing like bases, I need to subtract the exponents. X to the third over x to the first becomes x to the second. My bigger exponent was on top, just like the 88 was on top. So my answer is going to go on top, so I'm going to be left with 8x squared. There's not even a fraction anymore. Once you have that, once you get that idea of reducing first, it's going to save you so much time. There's no denominator to clear a radical out of. It's gone completely. So reduce, reduce, reduce first. Now if I take a look at this though, 8, I need to reduce that radical. Square root of 4 times the square root of 2. Square root of 4 is a perfect square, and x squared is a perfect square. So this is going to become 2x. Radical 2 is going to stay inside. And no more fraction whatsoever. Okay, so hopefully you got the good idea on that one. Remember, always try to simplify first. Look for perfect squares, look to simplify radicals, reduce the fraction if it's all inside, or reduce outside with outsides or insides with insides, right? Reduce, reduce, reduce first. If you end up with a radical in the denominator, rationalize it. Multiply the top and the bottom of the fraction by the radical on the bottom to clear it. And then don't forget to always try to simplify before and after you divide.